In the 3 years since generative AI entered higher education, we've witnessed a radical acceleration in academic output. However, a specific paradox is beginning to emerge. As production speed increases, the depth of student reasoning often declines. To find the cause, a 2026 systematic review examined how ChatGPT influences cognition. Starting with 409 academic records, researchers used Prisma filtering to isolate high-quality evidence, narrowing the field to 67 empirical studies. This dataset shows exactly how AI alters the thinking process. These studies suggest that generative AI functions as an environmental variable rather than a direct biological enhancer. Its impact on the human brain is dictated by the conditions we build around it. This concept is known as instructional ecology. It encompasses the pedagogical rules, task structures, and cognitive boundaries that define how a student interacts with the model. When we fail to design that environment, the algorithm defaults to designing our cognition. If the interaction lacks structure, the machine handles the analysis while the human mind remains passive. However, the data also contains a powerful counterpoint. When utilized under the right conditions, these same tools trigger significant spikes in human higher-order thinking. The key requirement is epistemic friction. This is the mandatory mental resistance, the active struggle to verify and refine, that is biologically necessary to build cognitive capacity. To map this, we look at the 33 studies that tracked both critical and creative thinking simultaneously. 18 of those studies documented synergistic enhancement. In these cases, users combined creative ideation with analytical validation, causing both domains to grow together. The ideation gains were significant. Across 31 out of 44 studies, researchers observed spikes in creative thinking when students used AI specifically for early-phase brainstorming. In these environments, AI acts as a structural scaffold. It allows students to rapidly experiment with tone and stylistic variation while testing new conceptual combinations. 27 studies also tracked gains in metacognitive engagement. This occurred when tasks required students to write their own draft first, then actively analyze the differences between their work and the AI's output. Reasoning improved further in 22 studies, where AI was positioned as a dialogic partner, specifically used to generate counterarguments that the user had to then dismantle. These outcomes only materialized when task rules forced the user to justify their choices. The cognitive growth was a result of the requirements placed on the human, not the capabilities of the machine. In unstructured environments, where students simply requested a final answer, these benefits vanished. Epistemic friction is the mechanism that drives this synergy. Without that active mental struggle, the cognitive gains observed in the research simply do not occur. Without that friction, the relationship reverses. Using AI passively creates an illusion of competence that can lead to rapid cognitive decline. 21 studies documented a passivity epidemic. When tasks lacked structure, users offloaded their analytical work to the tool, leading to cognitive laziness. This extended to original thought. 20 studies proved that without guidance, users stopped generating their own ideas entirely, defaulting to the AI's first suggestion. This is driven by semantic fluency, the AI's ability to generate incredibly smooth, articulate text in seconds. That articulation tricks the brain. Because the output sounds confident and professional, we assume it is logically sound. This fluency masks deep logical gaps, presenting a polished surface over an empty reasoning structure. This triggers premature closure. We accept the first output the AI generates, bypassing the critical evaluation phase that is central to deep learning. 15 studies tracked a resulting flattening of personal voice. When students relied on the tool's fluency, their work lost its emotional nuance and authenticity. In 8 studies, researchers identified an asymmetrical trap. Users felt creative, generating more ideas, but their critical depth plummeted. In the 4 most severe cases, researchers documented joint cognitive erosion. Without structured challenge, both creative and analytical domains began to atrophy. In these scenarios, the AI functions as an authoritative answer provider rather than a provisional partner. The human mind is removed from the loop. Semantic fluency sabotages the evaluation process. It transforms a potential cognitive amplifier into a tool that hides the user's own lack of understanding. To survive this shift, we have to engineer epistemic friction back into our workflow. We have to design the struggle. The primary defense is a cycle of self-regulated learning, or SRL. These are structured routines that ensure we maintain cognitive control rather than offloading it. 21 studies show that binding AI within iterative models keeps the human brain engaged. This cyclical defense has 4 stages: plan, prompt, evaluate, and revise. First, plan. Before starting the chat, you must define the cognitive boundary. You decide what you will think through yourself and what specific data you need from the machine. Next, prompt. Instructions must be designed to generate possibilities, not finalities. You ask for counter-arguments or stylistic variations rather than a completed task. Stage 3, evaluate. In 19 studies, researchers found that gamifying error detection, actively hunting for logical hallucinations, acts as a powerful cognitive builder. Finally, revise. You execute the final edits without AI assistance, justifying every change. This keeps the heavy intellectual lifting localized in your own mind. Consistent use of these cycles fosters a habit of epistemic vigilance. It creates a practiced defensive posture against the comforting pull of smooth AI fluency. By enforcing these protocols, you ensure a strict division of labor. The machine provides the raw material, but you execute the actual thinking. Generative AI is a powerful environmental variable. It can either accelerate your cognition or replace it, depending entirely on the rules you enforce. Let the AI generate the probabilities. You enforce the reality. You have the agency to design this ecology. Don't let the speed of the output dictate the depth of your thought. For more deep dives into the science of thinking in the age of AI, subscribe to Insight Inquiry. What are your protocols for checking AI output? Share your verification strategies in the comments. Because while the model provides the text, the responsibility for the reasoning remains with you.